Okay, I'm going to do the polynomial one now. So if you're got the complete the square done and you're ready to do the polynomial, I will quickly walk through that. The last one was pretty quick too. These are just so that since I'm not explaining them live, I'm just trying to get them done really quick. I hope they're complete and that you can follow them. You can always in YouTube hit the little gear icon and choose speed and slow me down. And you can always stop and rewind and watch things a couple times. So I'm just trying to get everything in the video. You can slow it down. Okay, so actually I should have gotten a little more ready. So this is Polynomials 1. I think we did some of this already. Let me present my screen. Okay. Yeah. So the first one is vocab. The degree of a polynomial is the power. Well, I guess let me mention a little something more about vocab. When you have something raised to a number, so this is x times itself 7 times. We call this the 7th power of x. This altogether is a power. 7 actually isn't a power. X to the 7th is a power. It's the 7th power. X is called the base of the exponent, the base of the power, and 7 is called the exponent. So a lot of people say that, what's the power? It's 7. Actually, the whole thing is the power, technically. But anyway, hopefully I won't make that mistake too much. But it's just a technical jargon. So the degree, what we call the degree of a polynomial, is you take what we call the leading term, the term with the highest power of x. This term, we call it leading because when you're close to the middle of the graph, all these things play a part and interact and make it look funky. But when you go way out to the edges, like way out to high positive numbers or high, very big negative numbers, the highest power dominates the other powers. The other powers get drowned out by the effect of this highest power. So we call this the leading term. And the number multiplying the highest power, we call the leading coefficient. So the degree is just the exponent on the highest power. So this would be degree 7. The leading coefficient would be -3. And the maximum number of real zeros, if you remember in a previous video, we talked about how polynomials, depending on the degree, can possibly, the maximum number of turnaround points. So this function will do something like this, and then it's going to have potentially six turnaround points. It's always one less than the degree. So it could turn once, turn twice, turn 3 times, turn 4 times, turn 5. Well, I'll draw a picture. So it could turn once, twice, 3 times, 4 times, 5 times, and then 6 times. So it's always the turnaround points, always one less than the degree. And potentially a line going through the polynomial could have up to 1, 2, 3, 4, 5, 6, 7 maximum intersection points. Now it's possible that, maybe this one, instead of maybe it could do something like this. So maybe it only crosses once. But maximum, there can be 6 turnaround points. Doesn't really have to be 6 turnaround points. Depends on the other terms beyond the leading term. But at maximum, it could have 6 turnaround points and 7 intersections of a horizontal line. So that maximum number of real zeros is 7. Okay, so they show the graph, x cubed minus 6x, and then they want you to estimate where, what input do I have to put into this function to hit 8 as an output. So remember, the inputs are the horizontal values and the outputs are the vertical values on a graph. So where is this function at height 8? Well, it's maybe over here, and you got to get close. It's just shy of 3 horizontally. So maybe 2.9, 2.8. I think if you get close, it'll take it. But if the precision is kind of annoying, let me know. If you're close, I'll give you credit. If it marks you wrong, I hope it gives you, I hope there's some sway here. Like, so if you did 2.85, I would hope that it would give you a point. Okay, now they give you the function x cubed minus 6x minus 1. Where is that equal to minus 10? So that's pretty much the same. I'm going to go down to minus 10. Where is this thing equal to minus 10? Well, over here at minus 3. That's how you do those. Okay, so the zeros are wherever the height of the function is 0. So wherever, so we're looking for where it crosses the horizontal axis, or at least touches the horizontal axis. It happens at -6. It happens at negative or positive 1. And it happens at 6. So, so just to go to Desmos, and let me show you what these functions look like. Here's x, so that's 1 power of x. Here's x squared. Notice it crosses at 0. But maybe I'll do this at a slightly, let me do it as x, oops, minus 1. So if I got one of these, and you know, if I do this, that's the same as it squared, or it cubed, or it to the 4th, or it to the 5th. So that's the idea. I want to talk about multiplicity of these factors. If you have one of them, it passes right through at 1, the opposite of that number. So 1, it passes right through it. If I have 2, a multiplicity of 2, or if I have x minus 1 squared, that's the same. Then it touches at 1, but it's like a parabola. It turns around, but pretty quickly. It kind of just like quickly glances it. And then if I have a multiplicity of 3, it kind of starts to look a little parabola-like. It's like, whoa, it's like flattening out, like it's gonna do the parabola thing. But then it mirror images it. It does actually pass through. Whenever it's odd, an odd number, 1, 3, 5, 7, it will pass through. But it gets flatter and flatter the higher your powers. So what if I have 4? Well, it's kind of like the parabola. Here's the parabola again. So it glances. It just barely touches. But the 4, instead of 2, 4, it gets flatter. It kind of, I don't know. It looks more like a cup, like it could almost stand, like it's more stable. Whereas this, if you had a cup like this, it would just fall right over. that looks a little more stable. A 5 does the same thing as a cubic, but it goes even flatter. 6, did I do 6? Yeah, that's 6. It's even flatter than the 4, and so that's what you're looking for. Yeah, I believe the page. So this one, it passes through, but it's not like this. It doesn't go through cleanly, or like this, where it goes through cleanly. Here, it's like, no, and then it does it anyway. So at -6, we're going to say multiplicity of 3. And at the other ones, we're going to say multiplicity of 1. Because they pass through, so it's odd. But this one's flat, so that's got to be more than 1. And the answers confirm that. -6 has a multiplicity of 3. 1 has a multiplicity of 1. And 6 has a multiplicity of 1. All right, here we go. -4, that's a clean one. So that's a 1. Here's a quick turnaround. So that's a 2. So at 0, multiplicity 2. This one, it doesn't want to pass through, but it does. So it's a 5, but the multiplicity will be 3. And so 0, 2, -4, 1, 5, 3. Okay, so the polynomial of degree 3 has roots of multiplicity 2 at x equals 5. Well, x equals 5, well, if that's a 0, then we'll subtract 5 from both sides. So -5, -5, you get, so that's one of the zeros. So this is actually the linear factor. So if you want it to cross at x equals 5, this is your factor. It has a multiplicity of 2, so I've got 2 of those. And it has a root of multiplicity 1 at x equals -3. So just flip the sign on that and you get x plus 3. And that's pretty much the function. It does say it has a y-intercept at -52.5. So if I make x 0, I need this number to equal -52.5. So if I put in 0 for x, I'll get -5 squared, that's 25. And if I put in 0 for x, I'll get 3. So 25 times 3 is 75. How do I make 75? I'll write this out. If I have 75 and I want to turn it into -52.5, was that right? Yeah. How do I do that? Well, I need to multiply 75 by a number to make -52.5. What is that number? Well, let's solve for it. Whatever that is. So if I go to my calculator, since I can't do that, at least I don't want to, I get -0.7. Let's see if I did that right. So -0.7. Did I do it? Yeah, okay. So that's how you do that one. Okay, find a degree 3 polynomial having 3 zeros at -1, 1, and 8. The coefficient on x cubed equals 1. When they say that, they just mean there's no number that you got to put out here. You just got to do the factors. And for the factors, just flip the sign on these. X plus 1, x minus 1, x minus 8. That's all you need. Polynomial of degree 5. The leading coefficient is 1, so we have no number outside. Has roots of multiplicity 2 at x equals 2. So I'm going to have x minus 2 squared. And x equals 0. Well, x minus 0 or x plus 0. I can just write x. Okay, so and that has, so they both have multiplicity 2. So I have x minus 2 squared and x squared. And it has a root of multiplicity 1 at x equals -4. So I should also have an x plus 4. And you'll see that that's what we have. These have multiplicity 2. This is the x at 0. This is the x at 2. This is the x at -4. Altogether, we have 1, 2, 3, 4, 5 degrees. Or, yeah, degree of 5. 5 linear factors. Degree 4, so we need 4 things. 2 of them are at x equals 4, so we're going to have x minus 4 squared. And then we're going to have 1 at x equals 0, so we'll just put an x. And we'll have 1 at x minus 3, so we'll put x plus 3. So I'll go ahead and I'll show you the answer, but we got to make it go through this point here. So how do we figure out that number here? So we have the x, that was multiplicity 1 at x equals 0. We have x equals -3, so we have an x plus 3 here, and we only have one of them. And then we have 2 at x minus 4. How do we come up with the 0.3? Well, because it had to go through this point. So let me see if I can remember that. Well, let me see if I can pull this up on another screen. This is 9. Okay. So once you know, you got some number that you don't know, and then you have x. You have x minus 4 squared, and you have x plus 3. You know it goes through the point 5, 12. So that means you got to plug in 12 for y and 5 for x. 5 minus 4 is 1, 1 squared is 1, 5 plus 3 is 8. And so you got to figure out what n is. So you have n is equal to 12 over 40. If I cancel out a 4, I get 3 over 10. So that's 0.3. I'm sure they would take 3 over 10. That's how they got the 0.3. What is the least degree possible for the polynomial graft? Well, the number of turnarounds is always 1 less than the degree. So I have 1 turnaround, another turnaround, and another turnaround. So this has got to be 4. What is the least degree possible for the number of grafts? Well, we can go by turnarounds or we can go by intercepts. I think turnarounds is best. 1 turnaround, 2, 3, 4, so it's 5. The polynomial of degree 3 has roots of multiplicity 2 at x equals 4. So we're going to have x minus 4 squared, and multiplicity of 1 at x minus 2 equals -2. So we're going to do x plus 2. And then there's a y-intercept of this. So I'll show you the answer, and then we will show how to get it. So we had y is equal to some number we don't know, times x minus 4 squared times x plus 2. I think I'm doing the right one. And it said it had a y-intercept at y equals -3.2. That means when x is 0, y is -3.2. So just plug in 0 for x, because the y-intercept is where it crosses, you know. I guess I should put it down here. It's at x equals 0. That's where the y-axis is. And this is where it crosses, so plug 0 in for x. -4 squared is 16. 2 times 2 equals -3.2. Well, this is 32. So n is equal to so that's 32 divided by 10, so this should be 1/10, negative 0.1. You could do that on your calculator. And so that's how they got the negative 0.1. They find the degree, 7. Leading coefficient, negative 4. And constant term, that's the term that doesn't vary. It has no variable, so that's 3. Find the degree, 7. Leading coefficient, when there isn't a number there, it's assumed to be 1. Okay, pick the graph which is the following. So it crosses at x plus 1 and at 0, but 0 is a double. So that means it's going to touch at 0, but it's not going to pass through. So it passes through cleanly at 1, like this, just like that. And then it just grazes at 0. So it's this one. I guess I already did those. Okay, so it's going to cross at -2, -3, and -4 cleanly. We've already answered it. -2, -3, -4. Nice. Pick the graph. Okay, it's going to go through -2 cleanly. This one, and then it's going to touch at 1, but it's a double root, so it's just going to graze it. So it's this one. Pick the graph, -4 cubed. So it's going to cross at 4, but it's not going to look like it wants to. So this is it. Okay, a box without a lid is constructed from a 20 by 20 inch piece of cardboard. We're going to have to pull this up on another screen. By cutting x-inch squares from each corner and folding up the sides. Determine the volume of the box as a function of x. All right, so 20 by 20. I'm going to cut x by x corners. These are common problems. And if I cut those out, I can fold these sides up and make a box, a square, kind of square box. Like that. Okay, so the sides are now 20 minus twice x by 20 minus twice x. So the volume would be that. What are they asking? Yeah, they want the volume. I mean, you could factor out 2's. So, I mean, if I factor out a 2 of this, and I factor out a 2 of this, you could have that. So that's 4. And to flip these around, you could put a minus. You could pull a minus out. So if I pull a minus out, I could get x minus 10. You can change this direction because, you know, 3 minus 5 is the opposite of 5 minus 3. So you can, if you pull a minus out, you can flip the subtraction. So if I pull a minus out, I can flip that subtraction. If I pull another minus out, which makes it positive again, I can flip that. So I don't know what exactly they'll take. It could be this, which is kind of tricky. You know, this is pretty easy here because you can take the x's off, and then you just see that this is no longer 20. You've taken x off of 20 twice. So I think, let's try this. Let's try 20 minus 2x squared. See what they want. 20 minus 2x squared by x, yx. What? By x. Oh, I get it. Sorry. this is the base. So like the base of the area is 20 minus 2x by 20 minus 2x. The height is going to be x. So I should have had an x there. So there should have been x's all along. I get that. Use a graphing calculator to approximate the values of x that produce a volume of, oh, that's kind of tricky. Well, you can use Desmos. So you could go to so you can say x 20 minus x minus 2x squared equals, what number do they want? 562.5. Does it give me an answer? So looks like 2.5 and 4.243. The largest reasonable answer. So I mean, you could do that. Okay, given a function this, find the y-intercept. So just plug in 0. So it's 0 because anything times 0 is 0. So its x-intercepts are, so where does it equal 0? Well, that's going to be at 0, at 2, and at minus 5. They want them in order of smallest to largest. So the minus 5 will go first, the 0 will come next, and then the 2 will come after that. And then this is end behavior. I did a lot of these, didn't I? I might take these off for now. I'm going to put these on a separate thing, and we'll do that because we haven't gone over end behavior. So I'll put these on a separate assignment. But these ones down here, we've done those already. We've done those. These ones here, though, I'm going to put on a new assignment. I might put the box on a new assignment, too. We'll go over that. And then these you should be able to do. List the zeros. It's 3 and 0. This one's 0. Set this equal to 0. So 2x plus 5 equals 0. Subtract 5 from both sides. You get 2x minus 5. Divide by 2. You get minus 5 over 2, which is minus 2.5. So yeah, those I think you can do. But I'm going to move those ones to another assignment, and we'll talk about those separately. All right, so that's covers the polynomials. So if you're kind of a little bit ahead, you can work on those. I hope that was clear enough, even though I went kind of fast. You guys have a good day.